अच्छा. Okay, students, today we'll start a very important topic, that is Dalton's law of partial pressure. Before starting the topic, let's just understand what did the Dalton say. So the law says when two non-reacting gases are placed together, then the total pressure is the sum of partial pressure of each gas. Let's just understand one by one what does it even mean. First of all, the important thing is this word, when two non-reacting gases. What are non-reacting gases? The gases which do not combine together. For example, N2 and O2. Like you could say, some students might think that N2 and O2 combine together. No, N2 is highly inert gas, so it requires high temperature to combine with oxygen. Just think of the percentage of nitrogen atmosphere. It is 78%. If it would have been so reactive, then do you think it would have got 78% in the atmosphere? No, we would have not. So N2 and O2 are non-reacting gases. So the partial pressure law can be applied on N2 and O2. Other are CO2 and O2. These are also non-reacting gases. So Dalton law can be applied on these gases. And Dalton law cannot be applied on NH3 plus HCl. Why so? Because it forms NH4Cl, which has your white fumes. NH3 plus HCl combine together to form NH4Cl, which have white fumes together. So Dalton law cannot be applied on NH3 and HCl, but it can be applied on N2 and O2, CO2 and O2, and all the other non-reacting gases you have. First of all, this should be clear that what are reacting gases and what are non-reacting. Okay, let's move. It says, like, if you have two or more than two gases together, then if you combine them, like you have a container and you have gas A, and then you have gas B, and you have gas C. Okay, if the gas A has 5 atm pressure, if the gas B has 10 atm pressure, and if the gas C has 5 atm pressure. Okay, what are these pressures actually? What is this term partial pressure? The pressure exerted by the individual gas inside the container is known as the partial pressure. For example, the gas A is applying 5 atm pressure inside this container. So what will be the partial pressure of A? It will be 5 atm. I would denote it with PA. Okay. What is the partial pressure of B? It is applying 10 atm inside the container. So the partial pressure would be 10 atm, and I will write it as PB. Similarly for C, it would be PC. Now what did the Dalton say? Dalton said, if these gases are non-reactive and you have to find the total pressure, then he said just simply add them. You will get PA plus PB plus PC. What is PA? 5 atm. What is PB? 10 atm. And what is PC? 5 atm. Just add them. What will you get? You will get 20 atm. So that would be equals to the total pressure. Now it looks quite easy. Like if I take an example, if you have a box and you have 5 dairy milk chocolates, 5 5-star chocolates, and 10 are bourbon chocolates. Okay, and someone asked you what is the total chocolate, what will you say? 10 plus 10, that is 20 chocolates. It's quite easy, simple mathematics. Then why did it even become a law? If it is so easy and it's such a basic maths, let's just understand another thing. If I take a container, its mass is m, its volume is v, its temperature is T, pressure is P, and density is rho. Okay, fine. You have taken a container which has a mass of m, volume v, temperature T, pressure P, and density is rho. Cut it into half. If you cut it into half, what you'll get? The mass will get half. The volume will get half. What about temperature? No, it won't get half. It would be T. What about pressure? It would still be P. And what about density? It would be rho only. So you have seen here that while cutting the mass or while containing this container, something got halved while something remained the same. Like mass and volume, they got halved while temperature, pressure and density remain the same. So the properties which does not depend on mass are known as intensive properties. I for intensive, I for independent. So all those properties which are independent of mass are known as intensive properties, while the properties which depends on mass are known as extensive. So by looking at this example, what did you see? That mass and volume got halved. So these are extensive, while temperature, pressure and rho are intensive. Now we have understood what is the difference between intensive and extensive. Let's take one example. If you have two containers, it has 5 gram and it has 10 gram, and you mix both of these containers into a bigger container. The mass, you add them. And if someone asks you what is the total mass right now, what will you do? You will just simply add it. It is 15 gram. But if I say the temperature is T1 and the temperature here is T2, and if I mix them together, what will be the temperature? Will it be T1 plus T2? No, it won't. If I say the density is rho 1 and density is rho 2, and if I mix them, it will be the total density. Will it be rho 1 plus rho 2? No, it won't be. What do we conclude here? The thing is, if you have an extensive properties, then you can simply add them. But if you have intensive properties, those cannot be added. And pressure being intensive cannot be added like this. This is only after Dalton's law that we started adding it and making it to total pressure. So that's why this was made as a rule. Because it is quite easy. Like if someone says you have 5 chocolates, you have 10 other chocolates, what are the total chocolates? Then you will simply say 15 chocolates. It's nothing, not rocket science. Then if it was made a rule, then it must be something special. So what was the special thing about here Dalton was that before this Dalton's law, pressure could not be added like this. Because being intensive, you cannot add these properties. It is only after Dalton's law that we started adding them. So now, it's simply the law says that if you have partial pressure of gas A as PA and partial pressure of gas B as PB and partial pressure of gas C or any other gas as PC, and if you have to find the total pressure, you will simply say P total is equals to PA plus PB plus PC. Okay, and what are the partial pressure? Partial pressure is nothing but the pressure applied by a particular gas inside a container. How do we calculate partial pressure? This is the big question, which will help you to solve the questions. There are two ways to calculate the partial pressure. Like if you want to calculate the partial pressure, you can apply two formulas. Those are very basic and very easy formulas. For example, we all know ideal gas equation, that is PV equals to nRT. Okay, PV equals to nRT. What is P here? Pressure. What is V here? Volume. What is the volume? Volume of the container. N is moles. R is universal gas constant. 1 by 12 will take it, or 0.0821 atm liter mole inverse Kelvin inverse. And temperature has to be taken in Kelvin. Okay, P has to be taken in ATM, while volume has to be taken in liter. Let's take an example. You have to find the pressure or partial pressure of A. What will you do? You just apply PV equal to nRT. Here, if you have to find the partial pressure of A, just write PA. Volume will be the volume of the container. Don't think like this. Like if you have a container, volume of 5 liter, and if you mix gas A, B and C, gas A volume will be 5 liter. For gas B, the volume will also be 5 liter, and for gas C also it will be 5 liter. It won't be like that the gas A will be just taking this part and gas B will be this here and gas C will take this part. No, it's not like that. When you mix the gases, they spontaneously diffuse together. Okay, so the volume of the container, that is 5 liter, will be taken for A, it will be taken for B, and it will be taken for C also. If someone asks you what is the volume of the gas A, so you just simply say the gas of the volume of the container, that is 5 liter. And if someone asks you for B or C, same, it would be 5 liter only, because gas A will be spontaneously mixed throughout the container, and similarly gas B and similarly gas C. So here you have to simply take the volume of the container. Now the important thing, that is moles. If you find the partial pressure of A, then just take the moles of A. You can say like this: if you take the moles of A, then you'll get the partial pressure of A. If you put the moles of B, then you'll get the partial pressure of B. Similarly for C. And if I put total moles over here, then you'll get the total pressure over here. Okay, R will be same value, and temperature, whatever the temperature is given in the question, you just simply take this. So this is the first way to find partial pressure, that is apply PV equal to nRT, and if you want to find the partial pressure of gas A, just use the moles of A. And if you write PV equals to nRT, and if you use the moles of B, then you'll get the partial pressure of B. And if you apply PV equals to nRT, and if you use the moles of C, then you'll get the partial pressure of C. And if you apply PV equal to nRT, and if you use total moles, then it will give you total pressure. And according to Dalton, the total pressure is equals to PA plus PB plus PC. So the first method which we learnt is, if you want to find the partial pressure, just apply ideal gas equation, that is PV equals to nRT. And if you want to find the partial pressure of gas A, just use the moles of gas A. For gas B, similarly, and for similar cases, the other cases will be taken. Like if you want to find the partial pressure of any gas, just use the moles of that gas. And if you use total moles, then it will give you a total pressure. The other important way to calculate the partial pressure is, and this is quite an important formula, that if you want to find the partial pressure of A, just write the mole fraction of gas A into total pressure. That's it. If you have to find the partial pressure of any gas, just multiply its mole fraction with total pressure. This is quite an important formula which will help you in later topics also. So just remember it, thoroughly remember it, that if you want to find the partial pressure of any gas, just multiply the mole fraction of that gas with total pressure. That's it. You don't have to do anything else. Just remember two formulas, that first you have to apply PV equal to nRT. If you want to apply PV equal to nRT, then one thing you have to keep in mind, that if you are using the moles of gas A, then you'll get the partial pressure of A. And if you are using the total moles, then you'll get the total pressure. And the other formula is, if you have to find the partial pressure of any gas, multiply its mole fraction with P total, that is total pressure. What is the mole fraction? I hope you know it. What is the mole fraction? Mole fraction equals to mole fraction of A. Let's just take it. Moles of A divide by total moles. Okay. So if you have to find the mole, if you want to find the mole fraction of any gas, just write its moles and divide it by total moles. You'll get the mole fraction of gas A, B, C, anything. Just if you want to find the mole fraction, just write the moles of that particular gas and divide it with total moles. Okay. Let's take an example. If I take gas A, its moles are 2, gas B again 2, and gas C, it is 6. Find the mole fraction of gas A. What you'll do? How many moles do we have? 2. Divide by total moles. Total moles 6 plus 2 plus 2. How much? 10. If you want to find the mole fraction of B, what will you do? Moles of B 2 divide by total moles. Add them. 10. Mole fraction of C. How many moles do we have? 6. And what is the total moles? 10. And this way you'll get the mole fraction. Okay. And if you multiply with the total pressure, you get the partial pressure. The data will be given in the question. So what we have studied? We have studied that according to Dalton, if you have 2 or more than 2 non-reacting gases, and if you want to find the total pressure, just simply add them. Add the partial pressure of those individual gases. We have also studied that we have intensive properties and we have extensive properties. Intensive properties which are independent of the mass, and extensive properties which are dependent on the mass. Okay, so intensive properties cannot be added and extensive properties can be added. Pressure being the intensive properties could not be added before. Only after this law we have started adding the individual partial pressure and making them equal to the total pressure. To find the total pressure, you have two very important formulas. First is ideal gas equation, that is PV equal to nRT. If you write the moles of gas A, then you will get the partial pressure of gas A. And if you write the total moles, then you will get the total pressure. And if you write B moles or the moles of C, then you will get the partial pressure of those gases. Next, very important formula that we have studied, that if you want to find the partial pressure of any gas, just find its mole fraction and multiply with total pressure. What is the mole fraction? Mole fraction of any gas is equals to moles of that gas divided by total moles. Okay. So I hope this much is clear now. Second very important thing, like if you have gas A, gas B and gas C. Okay. If the question says that you have added, if you have added plus 1 moles of A, like you have added 1 more mole of A, and you have removed 2 moles of C, then what will happen to the partial pressure of every gas? What you have done? You have just added 1 mole of A and you have removed 2 moles of C. Now the question is, what will happen to individual partial pressure? That what will happen to partial pressure of A, B and C? Will it change or will it remain the same? Just remember, if you add or remove any gas, if you add the moles of any gas or if you remove the moles of any gas, then the partial pressure and total pressure of that gas will change. But the one which you have not altered or which you have not affected, then the partial pressure which was before and the partial pressure right now will stay the same. So if you have added the moles of A and if you have removed the moles of C, then the moles of B was not altered. So the partial pressure of B will not change. It will not alter. This is a very important concept, that if you do not change the moles of a particular gas, then its partial pressure stays the same. It won't change. Okay. So the partial pressure of B will not change in this case. This you should know. Okay. So let's just sum up that Dalton's law is applied on inert gases or non-reacting gases. you can say the gases which do not react together. We have seen the example N2 plus O2, CO2 plus O2, and we have seen that NH3 plus HCl does not obey Dalton's law. Why? Because they form NH4Cl and it has white fumes. Then we studied a very important formulas of partial pressure, and now we will apply these formula in the questions. Let's apply it. We have given this question. Let's just read out this question. If 2 moles of A, okay, just write it. Whenever you solve the question, just write it. Just write the data given. It will help you to solve. It will help you to apply the formula, and it will even help you to solve the question very easily. Just write it. Moles of A. How many moles of A are there? 2 moles. 3 moles of B. So write NB equals to 3 moles. And final pressure is 10 atm. Okay, final pressure is 10 atm. Right, just write it with units also. Okay, just make it a habit for writing it with units, because it will help you if you have different units to convert it into the same unit. It will help you to do any question. Find partial pressure of A and B. Quite an easy question. Okay, you just have to apply the formula over here. What is the formula of partial pressure A? Multiply its mole fraction with P total. Fine. Similarly for B, multiply its mole fraction with P total. Let's solve that. How to find the mole fraction? Divide the moles of gas A by total moles. How many moles do you have? 2. Total moles 3 plus 2, 5, and total pressure is 10. Okay, just cut it. How much did you get? 4 atm. If you have to find the partial pressure of B, 3 divided by total moles, 5, and what is the total pressure? That is 10. Okay, how much do you have? 6 atm. Okay, this other way also. If you find the if you have found partial pressure of A, you have found partial pressure of A, it is 4 atm. Then you don't have to apply this formula and find the partial pressure of B. You know that partial pressure of A plus partial pressure of B must be equal to total pressure. This is the law. If you have partial pressure of A, that is 4. If you want to find the partial pressure of B, let it be PB. And what is the total pressure we have? 10 atm. What is the result you got? 6 atm. Did we get the same result by formula? Yes, we got the same result. Okay, so either you find the individual partial pressures, or you find the partial pressure of 2 gas. If 3 gases are given, then find the pressure of 2 gas and minus it by the total pressure. You get the partial pressure of third, because ultimately the total pressure is equals to the partial pressure of each and every gas which is present inside the container. Okay, got the answer? Understood? Let's solve the different question. What is the question over here? If in the previous question 2 moles of B are added. Okay, what was the previous question? Previous question was we were given 2 moles of A, 2 moles of A and 3 moles of B. We were given 3 moles of B. What is saying? In the same question, that is in the previous question, 2 moles of B are added. You have added 2 moles. Okay, so just add 2 moles. How many moles do you have? 5 moles. Okay. Then find total pressure and partial pressure of A and B. Okay, now here the concept comes. We have understood that if you alter the moles of a particular gas, then the total pressure changes and the partial pressure of that gas also changes. But if you have not altered the mole of a particular gas, then its partial pressure will also not change. So here the partial pressure of gas A will not change, and this will help us to solve the question. What was the partial pressure we calculated? Just look at here. partial pressure of A is 4 atm. So here also the partial pressure of A will be 4 atm. Okay, now apply the formula. What is the formula? Partial pressure equals to XA into P total. What is the partial pressure? 4. Mole fraction? Mole fraction will change now because you have changed the moles. Moles of A is 2. Divide 5 plus, now the total moles. Here B you have 5 moles and 2. How many moles? And here it is P total. What is the P total here? 14 atm. Okay, so we have got the answer. That is total pressure will be equals to 14 atm. We have to find the partial pressure of B. What is the way? There are two ways I told you. PA plus PB will be equals to P total. PA is 4 atm. You have to find PB. You have to find PB, and P total you have just calculated, that is 14. What will be the PB? It will be 4. It would be 10 atm. Okay. You can calculate the other way also. If you want to find PB, then it would be XB into P total. You have 5 moles, then you have 7 moles, and here you have 14. What will you get? You will again get 10 atm. So you can do it by any way. Like if you have P total, you have partial pressure of A, then you can calculate partial pressure of B. That's quite an easy way. Or you could just apply the formula, that is mole fraction into P total. Okay, I hope you understood it. Let's just quickly recall whatever we have studied. We have studied partial pressure, Dalton's law of partial pressure. First of all, you should know what is partial pressure. What is partial pressure? If you are given a container and if you are having gas A, gas B and gas C, then the pressure exerted by a particular gas is known as its partial pressure. And what did the Dalton say? That if you have non-reacting gases in a particular container, then the total pressure will be the sum of all the individuals partial pressure. That is P total will be equals to PA plus PB plus PC. Then we understood like why this law becomes so popular, because it's just simply the addition. Why? Because pressure being intensive could not be added like this. Only by this law we have started adding it. We studied intensive and extensive also. What is intensive? Which is independent of mass, and what is extensive, which is depends on mass. Then we found very important two formulas of partial pressure. That is, if you want to find the partial pressure of any gas, multiply its mole fraction with P total. And the other thing is apply PV equal to nRT. If you want to find the partial pressure of A, just use the moles of A. And if you use total moles, then you'll get the total pressure. We did two questions also. And before that, we should remember that if you're not altering the moles of a particular gas, then its partial pressure will also not change. Okay, I hope you understood the topic. If you have any doubt, you can ask. You will do some more questions on it. Try with the basic questions and then we'll take it to another level. Thank you.